Hello students, this side your PSRC sir and I welcome you again in this fantastic chapter and the lecture number 5. The chapter name is Chemical Reactions and Equations and today we are going to discuss about the redox reactions. So what are redox reactions and what are its applications? Where do we use these redox reactions? So let us study with the redox reactions. So what are the contents that we are going to study apart from the redox reactions, which are the part of only the redox reactions? And a redox reaction is a very vast topic as it has three major concepts. The first concept that we are going to study in today's lecture, the modern concept we are going to study in tomorrow's lecture. So here you see that the redox reactions finds varieties of applications. Where does it find the varieties of applications? As you see here, there a chemical compound is burning, so the burning is also a part of redox reaction. As you see, redox reaction has varieties of applications in pharmaceuticals, agricultural segments, commercial segments, and in the manufacturing of some products just like washing soda, baking soda, and etc. Most of the redox reactions you see and you come across in the burning, and you see them in your chemical reactions. When the chemical reacts, some of the reactions comes under the category of redox reactions. So let's start with the content, the redox reactions. Then we are moving on to the oxidation and the reduction reactions. Why? Because redox itself is a part of what? It is a combination of two words, that is red and ox. So stands for the reduction, while ox stands for the oxidation. So we are going to see them. Next we are interested in the oxidizing agent and the reducing agent. After that we will see some of the questions. We are going to practice some of the questions, and then we will move into the questions and assignment for you. The assignment is totally for you, so you have to do the assignment. So without wasting any further time, let us start with the redox reactions. So here you see the pictures in which there is a burning of, you see here here's a fire, the photographic film, the coloring of the apple, and the rusting which is happens on iron car. So these are part of what? These are part of all redox reactions. And if I define the redox reactions are simply the combination of oxidation as well as reduction. Yes, you are right, you heard it right. The redox reaction is a combination. They occur simultaneously. The redox reaction in which the oxidation and the reduction reactions occur simultaneously. Without oxidation there will be no reduction, and without reduction there will be no oxidation. So let us start with the oxidation first, then we will move on to the reduction. So what is oxidation? As the name suggests, oxidation means simply, if I tell it in the one line answer, that oxidation means addition of oxygen to anything, or I can say addition of oxygen to a substance. So here what are the substances that we are using? We are using here elements, or I can say compounds. So oxidation in one line definition, oxygen is the addition of oxygen to the substance. But as we have seen, the redox and the oxidation reactions has a variety, as a vast application. So we have to define it on the basis of some other elements also. So defining oxidation, that is, it's a reaction in which there is addition of oxygen. This I have already told you. What is the another part? That is, it has the removal of hydrogen. So you can define a chemical reaction, or a redox reaction is that chemical reaction in which the addition of oxygen takes place, or removal of hydrogen takes place, or addition of electronegative element takes place, or the removal of electropositive element takes place, depending upon which element are we using. So in short, I can define that a oxidation reaction is that reaction in which these processes occur. Either of these processes occur, or you can say, just for an example, if I'm having carbon, if it is burning, so it forms carbon dioxide. So since the burning of carbon is happening in the presence of oxygen, so I can say that the oxygen is being added up to the carbon. But what happens if there will be no oxygen available? Just for an example, if I use this reaction and it forms NH3. So in this reaction there is no oxygen. So can I define it on the basis of oxygen? No, I cannot. So I have to use what? I have to use these other definitions for defining the oxidation reaction. So we are going to deal with each one of them and how do I can find out whether the oxidation has taken place or not, and which reactions comes in the category of oxidation. If it is coming in the category of oxidation, it will definitely come in the category of redox reactions, because redox reactions are what? These are the combinations of oxidations as well as reduction reactions. So moving to the first point, that is the addition of oxygen. So addition of oxygen means what? That is oxygen is being simply added up to the element. So in the first case you have seen that oxygen is being added up with the carbon to form carbon dioxide. So since here you see carbon and here you see carbon dioxide, so oxygen has been added up to the carbon. So this is what? This is a kind of oxidation reaction. Second, similar case in which oxygen is also being added up to the magnesium, forming the magnesium oxide. This is a case of what? Addition reaction. In the next reaction you see the oxygen is being added up to the phosphorus. How it is being added up? The phosphorus reacts with the oxygen to form phosphorus pentaoxide. So this is also a case of what? Oxidation reaction. Moving to another example, we see that the hydrogen burns in the oxygen to form water. Hydrogen burns in oxygen to form water. This is also a case of oxidation reaction. Another example, when a metal reacts with oxygen, it forms metallic oxide. So the formation of metallic oxide is also what? It is also an example of oxidation reaction. So moving on to the another part, that is the removal of hydrogen. You see here that if oxygen is not available, then how can you define oxidation reaction? You can define it on the basis of hydrogen atom. If there is a removal of hydrogen atom from any compound, you can say that that compound has undergone an oxidation reaction. Just for an example, if you see H2S, in this case there is no oxygen available. So how can you define whether the particular reaction is oxidation or reduction? So here you see what? The hydrogen being removed from the sulfur. Here H2S, and when after the removal of hydrogen it becomes only S. So in this case the oxidation of H2S has taken place, because according to the definition, if there is removal of hydrogen from any substance or any compound, it is said to be oxidized. Moving to another example, that is H2S on reacting with bromine, it forms HBr plus sulfur. So here you also see that is the removal of hydrogen. The removal of hydrogen. So this is also an example of what? This is also an example of oxidation reaction. This is third example. Here you can count the number of hydrogen atoms. So the number of hydrogen atoms in this particular reaction is 3 plus 2 plus 1, that is 6, and the number of hydrogen atoms present in this compound is 3 plus 1, 4. So there is removal of 2 hydrogen atoms. That's why it has comes under the category of removal of hydrogen, or we can say example of oxidation reaction. The next example, similar, that is removal of hydrogen. Here you see a big equation in which HCl is combining with MnO2 or manganese dioxide to form MnCl2, water and chlorine gas. Here you see the HCl is there, and here you see only Cl2. So what happens here? The hydrogen is removed from the chlorine and there is addition of chlorine. So the first part is that the hydrogen has been removed. So since the hydrogen has been removed, so it has come under the category of oxidation reaction. So you have seen the oxidation reaction in the form of addition of oxygen and the removal of hydrogen. But what happens if the compound does not contain any oxygen or hydrogen? So it must have contained any other element. So depending upon these we have to define them. But before moving further, I want to tell you that what is electropositive element and what is electronegative element. Electropositive elements are those elements which has a tendency to donate the electrons. So which element donate electrons, metals donate electrons because they have excess of electrons. They donate electrons to attain the stability, or I can say to achieve the noble gas configuration. So metals comes under the category of electropositive elements because they form cations by donating one or more electrons. So now moving on to the electronegative elements. Electronegative elements are those elements which has a tendency to attract the bond pair of electrons towards itself. It means what? That they are deprived of electrons. They want to take the electrons from anything they want or from anywhere. So electronegative elements are those elements which have the tendency to attract the electron towards themselves. So they are forming what? They are forming, that is, anions, a negatively charged anions, that is anions. So you have understood what is electropositive element and what are electronegative element. Generally non-metal forms electronegative elements and metals form electropositive elements. So moving to the third, that is addition of an electronegative element. So addition of an electronegative element, just like an oxygen. Oxygen is what? A non-metal, and it is also a electronegative element. So apart, if oxygen is not there, then we have to deal with what? We have to deal with the electronegative element. If the electronegative element is being added up to the compound or any element or any substance, we can say, so that also comes under the category of oxidation reaction. Just like this, if iron, here you see iron and chlorine are reacting with each other. So here you see that there is no oxygen present. So when they react with each other, the chlorine reacts with the iron to form ferric chloride. So here you see only iron and here you see ferric chloride. So what happens in this case? There is an addition of chlorine. There is an addition of chlorine element. So when the chlorine adds up, so what is chlorine? Chlorine is an electronegative element because it forms Cl minus anion. So this is also an example of what? An oxidation reaction. Moving on to the another example, that is SnCl2, that is tin chloride. When reacting with chlorine, it forms tin chloride. So what is the difference in here? Its name is tin tin 2 chloride. The 2 is used because the valency of tin here is 2, and in this case the valency of tin is 4. So I will use the name tin 4 chloride. So that is the difference. The name is same, but you see in the parenthesis you have put the valencies. So that differentiates both the compounds of tin. So here you see 2 chlorine atoms are add up to the SnCl2. So it forms SnCl4. So there is also an addition of electronegative element. So now moving to the electropositive element, you see if in the oxidation reactions addition of electronegative element takes place, so there must also be in what? The removal of electropositive elements. So let us see that example also, that is the removal of an electropositive element. Just the same case as the oxygen is not present in any reaction. If the oxygen is not present, then what we have to deal with? We have to deal with the elements. The elements can either be electronegative or electropositive in nature. So here you see when potassium iodide is reacting with chlorine, it forms potassium chloride plus iodine. So what is happening here? Here you see that is the potassium iodide. It is formed from K plus cation and I minus anion. So K plus is what? K plus is a cation. It is, or I can say potassium is what? Potassium is electropositive in nature and iodine is electronegative in nature. So what is happening here? It is changing from I minus to I, or I can say simply that the potassium has been removed from the iodine. That's why the formation of I2 takes place. So since there is the removal of potassium or electropositive element from the substance, it has undergone oxidation reaction. This particular compound has undergone oxidation reaction. Another example you see, that is NaBr sodium bromide on reacting with chlorine, it forms NaCl plus bromine. So what you see here, you see that NaBr, this is in the form of Na plus and Br minus. So Na plus cation and Br minus anion. Or I can say bromine is electronegative in nature while sodium is electropositive in nature. So what happens when sodium is removed? When sodium is removed from this NaBr, or you can see only that sodium has been removed and there is addition of electronegative element. So since there is an addition of electronegative element, which is a bromine, or the removal of electropositive element, that is sodium, it has also comes under the category of oxidation reactions. So this you have seen what is oxidation reactions. So let me summarize it for you. Oxidation reactions are those reactions in which either addition of oxygen takes place, removal of hydrogen takes place, addition of electronegative element takes place, or the removal of electropositive element takes place. So now moving to the reduction. So what is reduction? Reduction is the opposite of oxidation. What? It is the opposite to the oxidation. So it's very simple for me. So in oxidation there is addition of oxygen. So in reduction there is removal of oxygen. As simple as that. So let us see what are the reduction reactions. So reduction reaction is a chemical reaction in which there is removal of oxygen and addition of hydrogen. So what will happen to the electronegative element? The electronegative element will be released, or it will be removed, and for the reaction to come under the category of reduction. So in this reaction there is removal of electronegative element. And what happens to the electropositive element? There is an addition of electropositive element. There will be an addition of electropositive element to come it under the category of reduction reaction. So in short, what can we say? We can say that reductions are those chemical reactions in which there is removal of oxygen, addition of hydrogen, removal of electronegative element, and addition of electropositive element. So seeing it with the help of example, that is the removal of oxygen. So here you see H2O on reacting with carbon, it forms carbon monoxide and hydrogen gas. So here you see what? H2O, and here you see what? H2. So what is happening here? That is the removal of oxygen from water. Oxygen has been removed and water has been converted to hydrogen gas. So this is an example of reduction. Remember, I have told you that oxidation and reduction occurs simultaneously. You can also see here that carbon to the carbon oxygen is being added up. So for carbon, what is happening here? For the carbon here, oxidation is happening. For carbon there is oxidation, and for water there is okay. Moving to the another example, that is when zinc oxide reacts with hydrogen, it forms zinc plus H2O. So here you see what? There is removal of oxygen from the zinc oxide. In another case, what you see? That is the removal of oxygen. And in another reaction, when copper oxide react with hydrogen, it forms copper and water. So here you also see there is removal of oxygen. So these are the examples in which oxygen element is present in the compounds. But what happens if there will be no oxygen element present in some compound? So let us see those examples also. That is the addition of hydrogen. So here you see hydrogen on reacting with sulfur, it forms H2S gas. So what is happening to the sulfur? Sulfur has undergone the addition of hydrogen to itself. So this is what? This is the reduction, or I can say the reduction of sulfur is taking place. Moving to another example, that is chlorine on reacting with H2S, it forms HCl plus sulfur. So what is happening here? Here you can see that here you can see the chlorine has undergone the addition of hydrogen to form HCl. So since there is addition of hydrogen, it is also an example of reduction reaction. Moving to another example, that is H2 plus Cl2 forms HCl. So in this case you see here, in this case you see that to the chlorine, what is happening to the chlorine? There is addition of hydrogen. And what is happening to the hydrogen? What is happening to the hydrogen? To the hydrogen, a more electronegative element is being added up. So addition of electronegative element is what? Oxidation. It is oxidation. While the addition of hydrogen is what? It is reduction. So from these examples you already have an idea that the redox reactions takes place, or I can say in the redox reactions the oxidation and reduction takes place simultaneously. So here the another example in which sodium is reacting with hydrogen to form NaH. So here there is an addition of hydrogen to the sodium. So in this case I can say the reduction of sodium takes place. The another example you see, in this particular compound there are only 2 hydrogen, and in this compound which is in the product there are 4 hydrogen atoms. So what is happening here? 2 hydrogen atoms are being added up to this particular compound. So this is also an example of addition of hydrogen which leads to the reduction reactions. Moving to another point, that is the removal of electronegative element. Just as same as we have seen in the oxidation case, what happens if there is no oxygen or hydrogen element present? What we have to deal? We have to deal with the electropositive or electronegative element. Here you see the another example in which FeCl3 on decomposes to give FeCl2 plus chlorine gas. So here you see there are 3 chlorine atoms, and here you see only 2 chlorine atoms. So what is happening here? There is the removal of 1 chlorine atom, and chlorine is what? Electronegative in nature. So it has come under the category of removal of electronegative element. Here you see there is the removal of chlorine atom. Moving to another example, that is FeS gives on decomposing, it gives Fe plus sulfur. So FeS giving sulfur, iron and sulfur. So what is happening here? There is the removal of electronegative element. So FeS, the removal of sulfur. So FeS has gone what? FeS has undergone reduction. So moving into the another point, that is the addition of electronegative element. So what is the addition of electronegative element? Just as same as we have seen in the oxidation reaction. So what is happening here? Here you see chlorine on reacting with magnesium, or I can say chlorine when combining with magnesium forms magnesium chloride. So since what is happening here? Addition of electropositive element. So to the chlorine, the electropositive element or the metal has been added up. So here it forms MgCl2. So chlorine has undergone what? Chlorine has undergone reduction. The another example in which I2 on reacting with mercury, or I can say iodine on reacting with mercury, it forms Hg2. So what is happening here? To the iodine, mercury has been added up. So it is also a case of reduction, or I can say there is the reduction of iodine taking place here. If you are interested in to find the oxidation, we can also see whose oxidation takes place here, because these are the examples of redox reactions, as along with the reduction, oxidation must also have taken place. So here you see the mercury. To the mercury, what is happening? There is the addition of electronegative element. So for mercury, oxidation. So for mercury, oxidation occurs, and for iodine, what is happening? For iodine, there is reduction. So here you see these are the examples of redox reactions. So let us move to the another topic, that is oxidizing agent. So what are oxidizing agent? Oxidizing agents are those substances which brought oxidation. Oxidizing agents are those substances which brought oxidation. Moving to the another category, that is reducing agents. So just like the oxidizing agents which brings about the oxidation, reducing agents are those substances which brings reduction in the reaction. Here you see their definitions. So we are not interested in that definitions. We have to work with the examples, because from the exam point of view, the questions are those which can make me gain more marks. So I have learned the concept, you have learned the concept, and moving to the examples. So here you see copper oxide on reacting with hydrogen forms copper and water. So what we have to find? We have to find first whose oxidation takes place, whose reduction takes place, what is the oxidizing agent and what is the reducing agent in particular this reaction. So what is happening here? Here you see the copper oxide on reacting with hydrogen, it forms copper and water. So what is happening here? The removal of oxygen atom from the copper oxide and it converted to copper. So here that is the removal of oxygen. So removal of oxygen comes under the category of, that is, reduction. So the reduction of copper oxide takes place. What is happening to hydrogen? See here there is a hydrogen molecule and here you see there is water molecule. So here H2 and here H2O. It means that oxygen atom has been added up to hydrogen atom. So what is this process? This process, that is the addition of oxygen, is the process named or comes under the category of oxidation. So we have seen that copper oxide have undergone, or I can mark it, that copper oxide has undergone reduction and hydrogen has undergone oxidation. So I again mark it. But what about the oxidizing agent and reducing agent? See what element is, see in this case which substance is brought oxidation. For the oxidation of hydrogen, from where the oxygen comes? Oxygen comes from the copper oxide. That is, this substance has undergone reduction providing its oxygen to this element. That's why its oxidation takes place. So copper oxide will be acting as the oxidizing agent. So copper oxide will be acting as an oxidizing agent. And what is happening to hydrogen? What is happening to hydrogen? Hydrogen is being oxidized. But for the oxidation, what is acting as an oxidizing agent? Copper oxide is acting as an oxidizing agent. Now let us see the reduction of copper oxide takes place. So how the reduction of copper oxide takes place? If hydrogen is not interested in taking up the oxygen, will the reaction proceed on? No, the reaction will have not proceed on, and also the reduction of copper oxide will have not undergone. So just because that hydrogen has take the oxygen atom from the copper oxide, the reduction, or we can say the reduction of copper oxide takes place. So for the reduction of copper oxide, hydrogen is acting as what? Hydrogen is acting as the reducing agent. It is acting as a reducing agent. So what are the things that you have noticed in this example? The things that you have noticed in this particular example is, first of all, the oxidation and the reduction, the oxidizing agent, the reducing agent, they all comes from the reactant side. They all come from the reactant side. So this is the first most important condition that you remember, that the oxidation, the reduction, the oxidizing agent as well as the reducing agent, they all have to be from the reactant side. So this is the first important thing. Second important thing is that the substance which is reduced is acting as an oxidizing agent, and the substance which is oxidized is acting or will act as a reducing agent. So for the substance which is reduced will be acting as what? Oxidizing agent, and the substance which has been oxidized will be acting as a reducing agent. So these are the two major parts, or you can see these are the two major points that you always need to remember, because the redox reactions are the very important topic, because the examiner makes most of the question from this redox reaction. Also remember one thing, that the redox reactions covers many reactions, just like combination reactions comes under this category, as you have seen many examples in which the combination takes place. Just for an example, carbon is combining with oxygen to form carbon dioxide. So this is the category of combination reaction. Also it has come under the category of redox reaction. It means what? That the redox reaction, that for a redox reaction there are three categories. The combination reactions come under these categories, the decomposition reactions come under these categories, the displacement reactions, that just the single displacement reactions I can say comes under the category of redox reactions. So this covers a major part. So this you have seen. Let us summarize this so that you can write it in your notes. So let me erase the whole part. So here is the summary. So this was the example. Now we have to do some of the questions by ourselves. So moving to the question. So in this case, what you have to find the oxidizing, the reducing agent in the following reactions. Also name the substance which is oxidized and reduced. So you have to name the substance, you have to find the oxidizing as well as the reducing agent, and to find the oxidizing as well as the reducing agent, you first need to find which substance has undergone oxidation and which substance has undergone reduction. So here you see the reaction in which phosphorus is reacting with oxygen to form phosphorus pentaoxide. So what is happening here? The oxygen is being added up to this phosphorus. So this is what? This is what? This is oxidation of phosphorus. So, and here what you see, there is the addition of phosphorus. So for oxygen is more electronegative than phosphorus. Both are electronegative, but electronegativity is the tendency to attract the electrons toward itself. So talking about the oxygen attracts more electron towards itself than the phosphorus. So on taking in view for the oxygen, phosphorus is what? Phosphorus is not as much electronegative as much as oxygen. So in respect to oxygen, phosphorus behaves, or phosphorus looks like as an electropositive element. So here you see what is happening, there is an addition of electropositive element. So since there is an addition of electropositive element, what it is called? It is called as a reduction. So here you see the phosphorus has undergone oxidation, the oxygen has undergone reduction. So the next thing, that is what are the oxidizing agent as well as the reducing agent. Since phosphorus here is bring the oxidation to occur, so it will act as a reducing agent. So it is reducing agent, and since oxygen is bringing the reduction, so it will be the oxidizing agent. So here you see, you have find out the reducing agent, you have found out the oxidizing agent. Also you have seen which element or which substance has undergone oxidation and which substance or the element has undergone reduction. What was the another part? Name the substance which is oxidized and reduced. So which is oxidized? You have to name them. So what is oxidized? Oxidized is, that is phosphorus. So name is So the name of the substance which is oxidized is phosphorus. The name of the substance which is reduced is oxygen. So the reduced substance is oxygen. So here you complete this example. Moving into the another example, that is the same. What you have to find? You have to find the reducing agent, you have to find the oxidizing agent, you have to name the substances which is oxidized and reduced. So here you see what is happening here. Here is the reaction between copper and oxygen to form copper oxide. So copper on reacting with oxygen forms copper oxide. So what are the oxidizing agent, reducing agent? So copper adds up the oxygen to form copper oxide. So copper is being oxidized here, while the oxygen is adding copper, and copper is what? Electropositive element. So addition of electropositive element is what? It's a reduction. So here what you see, the copper is acting as the copper here is acting as a reducing agent, while the oxygen here is acting as a oxidizing agent. If you have to name the substance, you can write the copper for Cu and oxygen for O2. Moving to another example, that is H2S on reacting with Br2 forms 2Br plus S. You see this reaction is balanced chemical reaction. So here what you see, that for H2S forms S. So say there is removal of hydrogen. So the removal of hydrogen is again what? Oxidation. So removal of hydrogen is what? Oxidation. You have seen it here. While for the bromine there is addition of hydrogen. So for bromine what is happening here? For bromine here reduction is happening. So what are the reducing agent as well as the oxidizing agent? The substance which is getting reduced is acting as an oxidizing agent. So here H2S is what? H2S is reducing agent, while the Br2 or the bromine is oxidizing agent. If you want to name, you can name it H2S as hydrogen sulfide, and this is Br2, or you can say bromine gas. Next question, the same question, finding the oxidizing agent as well as the reducing agent. So sodium when reacts with hydrogen form sodium hydride. So Na has undergone the addition of hydrogen, while the hydrogen has gone the removal of one hydrogen atom. Here two hydrogen atoms are there, and here only one hydrogen atom is there. So it has gone removal of one hydrogen atom, and the removal of hydrogen atom is what? It is oxidation. While the addition of hydrogen is what? It is reduction. So name the substance which is getting oxidized and reduced. The substance which is getting oxidized is hydrogen, while the substance which is getting reduced is sodium. So what are the oxidizing as well as the reducing agent? So here you see sodium is acting as a oxidizing agent, while hydrogen is acting as a reducing agent. So it is acting as what? It is acting at reducing agent. Moving to another example, that is chlorine on reacting with magnesium forms magnesium chloride. Here you see this particular kind of reaction is combination reaction, and since the element are combining to form a compound, so this is also called as synthesis reaction, and they come under the category of redox reactions. How? Let us see. So chlorine on addition of magnesium forms magnesium chloride. So here you see there is addition of electropositive element, and addition of electropositive element is what? It is reduction. And for the magnesium what is happening? for the magnesium electronegative element is being added up. So addition of electronegative element is what? It is oxidation. So here you see, for chlorine reduction takes place and for magnesium oxidation takes place. So chlorine will be acting as, chlorine will be acting as oxidizing agent. While magnesium will act as reducing agent. So these are some of the examples that you must practice. Moving to the another example, that is Nabr on reacting with chlorine forms 2 NaCl plus Br2. So here what is happening here from Nabr? So what is happening here from Nabr? It forms Br2. So there is removal of sodium atom from Nabr. So the removal of electropositive element, from any compound is termed as, yes, oxidation. So here it is what? Oxidation. While the chlorine adds up the sodium. So the addition of sodium to chlorine, and sodium is what? Sodium is electropositive element. So the addition of electropositive element, is what is termed as reduction. So it is termed as reduction. So NaBr undergoes the removal of sodium, that is the removal of electropositive element, while the chlorine has undergone the addition of electropositive element, and the removal of electropositive element is called as oxidation, while the addition of electropositive element is termed as reduction. So NaBr here, sodium bromide, is acting as reducing agent, or I can simply write Ra for reducing agent, while the chlorine Cl2 is acting as oxidizing agent. So for oxidizing agent I am writing here OA. So at last let us summarize what we have studied here. So for oxidation and for reduction, so for oxidation you have seen the addition of oxygen, while for reduction you have seen the removal of oxygen. On the basis of hydrogen there is removal of hydrogen, and in the oxidation and in the reduction there is addition of hydrogen. If we talk about the electropositive element or the electronegative element, in the oxidation there is addition of electronegative element, while in the reduction there is removal of electronegative element. At last, talking about on the basis of electropositive element, this we have already seen in the last example, that is the removal of electropositive element is termed as oxidation, while the addition of electropositive element will be termed as reduction. So this is all about oxidation and reduction, and the an important thing, the substance which is getting oxidized will act as an reducing agent, while the substance which is getting reduced will act as oxidizing agent. So this here completes the redox part. So let us now summarize the types of reactions that we have studied from the previous lecture and in this lecture. So the types of chemical reactions. So what are those chemical reactions? They are the combination reactions in which the elements or the compounds combine to form a new product. The second category is decomposition reaction, in which a compound breaks down into two or more simpler substances. The third is displacement, in which you have seen the more reactive element displaces the less reactive element from its salt solution. Next category is double displacement. So what you have seen in the double displacement, you have seen the mutual exchange of ions, or you can say the mutual exchange of radicals in the compound which are taking part in a chemical reaction. And the types of double displacement reactions are, first the neutralization reaction, and the second category is the precipitation reaction. The another type or the category that you have seen in the chemical reactions is exothermic and endothermic reaction. So in the exothermic reactions, what happens? Energy is released either in the form of heat, light or electricity. While in the form of endothermic reactions, what happens? Energy is utilized in the form of heat, light or electricity. Moving to the last topic, that is the redox reactions, in which the reduction and oxidation occurs simultaneously. So this is all about the chemical reaction. So here the assignment for you, take a look. So that's all for today's lecture. Thank you all. We'll meet next day.